Hi, and thanks for stopping by. Today we're going to be pitting the DMMCheck Plus high stability model against the 1983 Radio Shack Micronta top of the line multimeter with the range doubler. So here you go. This is the Micronta Radio Shack Range Doubler with 43 ranges, and it had a whopping 50,000 ohms per volt DC input impedance. So if you were measuring a circuit, it wouldn't load it down too much. But if you compare that with a modern meter, like, I don't know, a Fluke 87, this has got 10 meg ohm resistance per volt of input impedance. So it's really not going to load down your circuit. For a general purpose hobby meter, this has been great. First one I ever purchased back in 1983. So it's what, 40 years old? My goodness, it has been super reliable. The only thing that ever happened to it was some knucklehead had it in the ohms range and went to measure a 12 volt car battery and just fried it. There is no input protection, no fuses, nothing like that on these. So I went ahead and repaired it, and it's never been calibrated. It just is what it is. A simple meter, they're inexpensive. You can still find them on eBay sometimes. And this was my very first one, so I have, fond memories of using it. Nice thing about it, it gives you, there's the specs right on the face of the meter. It's a mirrored dial. I don't know if you can see that very well. There's a mirror, and that's to prevent a thing called parallax, which is when this little needle moves, you look at the reflection in the mirror, and that's really where your voltage should be. So if you're viewing it from an angle, you're supposed to look at the reflection in the mirror. I think it's more of a selling point. It gives you the ranges over here, and pretty simple to use. So here we go. Let's try it out on DC volts. So this is a 5 volt reference on the DMMCheck Plus. I'll hook it up, positive to positive. Switch this over to the proper setting, which is 10 volts DC. So I should get a deflection halfway. So here's my 0 to 10 volt scale. So it should be right in between the 4 and the 6, or mid scale here. So here we go. Let's see how this does. And there it is. Mid scale, right exactly where it's supposed to be. I'll show you the range doubler feature. So the more accurate these meters were, or the most accurate spot was higher up on the scale. So the highest resolution was the highest point of the scale. So range doubler, you flip the switch, this needle should double. So I should go from the halfway point all the way to the 0, and we'll see how that does. So wow, that's really close. So now I'm at a different scale. I went from the 0 to 10 to the 0 to 50, and the 50 now is a 5 instead of a 50. So it's pretty much exactly where it should be, but it's more resolution is the only reason they give you that. Also know that when you use the range doubler, your input impedance goes down from 50 k ohms to 10 k ohms. So something I never really used. It was good enough for most everything that I was doing. So pretty accurate on the DC scale. Let's try AC. So I'll turn this, undo the leads from the DMMCheck Plus. I'm going to switch the DMMCheck Plus to AC right here. So now the 5 volts is 5 volts AC. I'll turn my meter to the 0 to 10 AC, and I should get the same thing, a halfway deflection of the needle. And there we are. Yeah, so really accurate. I'm right here at 5 volts AC again. Great. Can this thing do current? Why, yes it can, as DC amps. So I won't be able to test AC current, but I can test DC current. So let's try that. I'll disconnect the leads, flip this over to the 0 to 5 milliamps, and then I'll reconnect my leads to the current side of things. Make sure I'm on DC, set it up for current, and I should be reading 1 milliamp, which on this scale again is the 0 to 5. So even though it says 50, that's 0 to 5 scale, and it should be at the 10. So right there it is. I am dead on 1 milliamp. So great. So it's working on amps. Let's try ohms, the setting that I had. I was the knucklehead. I'm the one that fried it. So we'll try ohms. Take the leads off. I'm going to flip it over to ohms. The lowest ohm setting is the 100 ohms, and it goes 100 ohms, 1,000 ohms, 10,000 ohms, and 100,000 or 100k ohms. So let's try the 100 ohm setting first. Hook up our leads and go to the... Oh, one thing about ohms, I forgot. I don't use this very much, and I almost forgot. Each time you set it up, this dial right here, you've got to zero out your ohm setting. So I'm going to go to the 0 to 100. I've got to turn this dial until the meter reads 0. So 0 ohms with the leads shorted together. And you have to do that for every scale change. You've got to change it. So I'll try it on the 0 to 1. Do it again. I'm going to zero out the meter. Trying to do this with both hands. Okay, it's zeroed out. I'm going to hook it up to the 100 ohm setting. Sorry about the shirt there. On the 100 ohm setting. This doesn't have to be on anymore. And I'm looking at my top scale now, and I should be at the 100. So it's pretty close to 100. I'm going to go up scale. I'll zero it again at 10, resistance times 10. And zero it. I'm going to go back to the 100. You can see this is not a precision instrument. It's close. It'll get you in the ballpark. For most general, like if you're working on an old radio or working on your car, testing your stereo, it's great. It's never a problem. So at the 0 to 10 scale, now 10 times 10 is 100, and I am right there on the 10. So it's much more accurate the more centered your scale is. So I'll try the R times 100, resistance times 100. And I'm going to move my leads again to the 1K position. And I should be over here at the 100. It doesn't quite make it, but you know the thing I didn't do? Again, you've got to zero out these meters. This is something that was really a pain then. It's a pain now, and you don't have to worry about it with most modern meters. So, okay, shorted it out. It's at 0. I'm going to go to the 10K position. And it should be at 100. And right there it is. Wow, this thing's holding up pretty well. And if I go now up a scale to the 1K, I'll zero it out again. Fun. This is so much fun. Put it back on the 10K leads. It should be centered now on the 10. So here I am, 10K, and for never having been calibrated and also having been smoked once and being 40 years old, this meter is doing really well. It is 40, right? So 83, 93, 2003, 2013, yeah, 40 years old. Wow, so there you go, right up there. And now the 100K position. So I'm going to test out all of this stuff on my meter here today. And there we go. Zeroed again. Go to the DMMCheck Plus. Put the leads on 100K ohms. It has a symbol for a resistor right here. And here I am mid-scale. 10 times 10 is 100, so 100K, and it is dead center. So pretty darn useful. Another feature of these, if you were running higher amps, it does have a 10 amp position, so you would move the red lead up here to your 10 amp position. And also, if you were running high voltage, like 1000 volts DC, which I would never use this meter for, then you could put the red lead up here to where it says 10,000 or 1,000. So that's everything that we can test with this, and it's done really well. I'm really happy with this meter. I still use it. It's so simple, so reliable. But there you go. There you have the 1983 Radio Shack Micronta Range Doubler. Thanks for stopping by.